Okay, this video is covering section 7.1, 0 and negative exponents. Now, you've learned about exponents before, but you've only looked at positive integer exponents. What I mean by that is if you take 2 squared, so the exponent here is 2, which is a positive number and it's an integer, meaning a whole number. So then 2 squared, we know, is 2 times 2, which is 4. So then if we continue on with this process, 2 cubed then would be 2 times 2 times 2, which is not 6, but 8. Let's do one more. So 2 to the 4th would be 2 times 2 times 2 times 2, which is 16. Now, you can see this pattern. As the exponent increases by 1, so as I add 1 here, then what's happening to the final answer is I am multiplying by a factor of 2. 4 times 2 is 8, 8 times 2 is 16. Because you're adding, you're multiplying by another 2. So each factor is increasing by 2. And we can continue on this process, but you understand what we would be doing to the 5th, to the 6th, and so on and so forth. But what if we went backwards? Okay, so what I want us to do is, I'm going to go backwards here. So I'm going to rewrite these. We're going to start with 2 to the 4th being 16, 2 cubed is 8, 2 squared is 4. Alright, one that we don't really talk about as much, but you have seen it before, is what if I have 2 to the 1st power? That means just 1, 2, right? So 2. So if you look at the pattern going backwards, what we're doing is we're subtracting 1 with the exponents. And so what's happening over here is we're now dividing by 2. So if I take away another 2, then what's happening is I'm dividing by 2. So typically you've stopped right there. You really haven't looked at, okay, what happens now if I have an exponent of less than 1? You might not have even thought about that. So what we're going to do is we're going to continue on this pattern. So what we're doing is we're going down as we're decreasing by 1 in the exponent. So our next value here would be 2 to the 0 power. And that is something that exists. So again, we have to follow this pattern. If you look on the right side, we're dividing by 2. So if we continue on with this pattern, and if I divide by 2, then that would mean that 2 to the 0 would be 2 divided by 2, which is 1, not 0. Because remember, exponents mean I'm not multiplying 2 times 0. It's how many times you're multiplying 2 by itself. And I don't have any 2's here. So if you look at this pattern, 2 to the 0 is 1. And actually, anything to the 0 power is going to be 1. 100 to the 0 power is 1. Negative 3 to the 0 power is 1. Okay, so that's really, really simple, and it goes for every single number. Anything to the 0 power is 1. Okay, now, what if we continue on? Now, what if I go and I subtract 1 again from 0? So that gives us 2 to the negative 1. So now, again, over here on the right, we're going to divide by 2. So what is 1 divided by 2? 1 half. All right, that's also something new for you guys because you might think that a negative exponent would make a negative number, but it does not. It makes a fraction. Okay, so let's continue on here. If I go 2 to the negative 2, that would be 1 over 2 squared, which is 1 over 4. Okay, or again, you can think of this pattern if I divide by 2 again. 1 half divided by 2 is 1/4. Continuing on, what do you think 2 to the negative 3 would be? Well, that would be 1/4 divided by 2 again, so that would be 1/8. Let's do one more. 2 to the negative 4th, 1/8 divided by 2 would be 1/16. So you see that I'm getting a smaller and smaller fraction. And actually what you can see the relationship here. If you look at 2 to the negative 4 as 1 over 16, 2 to the positive 4 is 16 as a whole number. Again, you can see the 8 and 1/8, 4 and 4, 2 and 1/2, and then we meet in the middle at 1. Okay, so that's how a 0 exponent or a negative exponent works. So to kind of sum all of that up, I want us to put down here as a summary, just kind of a 0 exponent and negative exponent rule. Okay, so just kind of make a little summary here. So first of all, we're going to have 0 exponents. and we're going to introduce this letter A. And we're going to say A is some constant, okay? It's some number. It could be 2, it could be 100, anything. So anything to the 0 power is 1. As long as A is not 0. If A was 0, 0 to the 0 power, that gets really weird, and we're not going to even go there, okay? So anything but 0 to the 0 power is going to be 1. All right, the next thing that we have is negative exponents. All right, so negative exponents. So if I have anything on A to, let's say, a negative 1 power, yes, negative 1, okay, then that would be, no, sorry, what I want is A to the negative n, and we'll say n is some integer, okay, some number. So A to negative n would be 1 over A to the nth power. All we do is create a fraction. Again, the answer is not negative, it makes it into a fraction. So if you have A, anything to a negative exponent, just put that underneath 1 and make that exponent positive. A couple of other applications here. We could also have, if I have 1 over A to the negative n. Now this time, my negative exponent is already in a fraction. So what that does now, if it's already in a fraction, then all you have to do is undo the fraction, and it becomes a positive. Okay? We have one more that I want to look at. What if we have a fraction, like A over B, and that's to a negative exponent? Then if whatever's in the top, in the numerator, is to a negative, that goes to the bottom, the denominator. Now, vice versa, whatever's in the denominator with the negative exponent gets moved to the numerator. So all you have to do, if you have a fraction to a negative exponent, all you have to do is flip the fraction and make the exponent positive. Okay? So these are our rules. So this is something that I would take your highlighter and I would highlight this in your notebook. Okay? So this is something that's very, very, very important. So you might even want to star it. Okay? Something that you definitely want to remember. Okay? Okay, so now let's look at some examples. So for example 1, we're just going to look at numbers. We're not introducing variables yet. So if I have 3 to the negative 3 power, okay, so our rule said that if I have a negative exponent, we want to make that into a fraction. So that's going to become 1 over 3, and then instead of to the negative 3, when I make it into a fraction, it undoes the negative exponent. So this becomes 1 over 3 cubed. Okay, so it's just following that rule that I wrote down before. So now we need to simplify this further and say, okay, what is 3 cubed? 3 cubed is 3 times 3 times 3, which is 9 times 3, which is 27. Okay, so 3 cubed, if I just have 3 to the positive, is 27, but 3 to the negative 3 is 1 over 27. Okay, second example is negative 2, and be careful, that's in parentheses, cubed. Notice here that the exponent is actually positive. What I did here is I made the number at the bottom be negative. I want to see what this happens here. What negative 2 cubed means is negative 2 times itself 3 times. You have to be very careful here with the negative because you have to make sure and cube the negative as well. So this has 3 negatives, so 2 of them are going to become positives, leaving you with a negative 2 times 2 times 2 is 8. So when you have an exponent, the only way to get a negative is if this number itself is negative. Then you have the possibility of getting a negative answer. Typically, the exponent does not make the answer negative. Okay, let's do one more example in this part. Let's do a fraction. So I have 2/3 to the negative 3. So the rule that I showed you before, if you have a fraction to a negative exponent, all you have to do is flip the fraction, and then you make the exponent positive. So what this means is 3 halves times 3 halves times 3 halves, which is 27 over 8. Okay? All right, another example here, we're going to add just one extra step in here. So remember, we need to follow PEMDAS whenever we are simplifying something. So we need to follow our order of operations. So that means exponents need to be taken care of first. But I want you to see, if I have 2 times 3, this is not 6 to the negative 2. I don't even want you to write that down, okay? Because what that would be doing is multiplying first. And you see here, exponents come first. So I need to take care of the 3 to the negative 2 first. So what this is I have 2 times 3 to the negative 2, remember, becomes a fraction, 1 over 3, then the exponent becomes positive. So this is 2 times 1 over 3 squared is 9. And when I multiply that across, it's really like 2 over 1, you get 2/9 as your answer, okay? Part B, next example. What if I now throw in some nice fractions? So 2/7 times 1/5 to the negative 1 power. So again, we don't want to multiply first, we want to take care of the exponent first. So the 2/7 I'm going to leave alone. Then the 1/5 becomes 5 over 1 because we had a negative exponent, and then that negative 1 becomes a positive 1. And so really that's 2/7 times 5 over 1, the first power, which is the same thing, and then multiply across, and we get 10 over 7. All right, the last example, for example 2, is going to look like this. What if I have 2 to the negative 3 over 5 to the negative 1? All right, so we have a fraction, but this time, instead of the whole fraction going to an exponent, we have each part, numerator and denominator, separate. So if I have 2 to the negative 3 in the numerator, what that means is that negative brings the 2 to the denominator, makes the 3 positive. Then the 5 to the negative 1 in the denominator, the negative makes the 5 move to the numerator, and then the 1 becomes positive. So all you're doing is you're flipping everything. You're flipping the signs and you're flipping the fraction. So then 5 to the first power is 5, 2 cubed is 8, and that is my fraction. All right, we're going to have one more example with 3 parts, and then we're done with this lesson. Okay, so for our last example, we're going to throw in some variables here and see how that works. So just like before with example 2, I've got 3 times x to the negative 2 power. So what happens is you want to take care of the exponent before you take care of multiplication. So I have 3 times x to the negative 2 is going to be 1 over x to the positive 2. And then when I simplify that, that's just going to become 3 over x squared. And x squared, we don't know what it is, so we leave it as x squared, and this is considered simplified. Okay? So part B, we have now almost the same exact thing, but now we have parentheses around 3x. How this changes is the 3x, the whole thing, is raised to the negative exponent. So when I do the fraction, the 3 actually goes down with the x because it's in parentheses. It also has the negative exponent. So there's that difference between A and B. Make sure you pay attention to that. In A, the exponent does not go with the 3. In B, it does. So now to simplify this, we actually have to figure out what 3x squared is. That's just simply as 3x times 3x. 3 times 3 is 9. X times x is x squared. So you can see that those two answers are different. All right, and last one for this example. We have 3 over x to the negative 2. All right, so this one is the opposite of part A. Now I'm dividing by x to the negative 2. All that means is the 3 is okay. It doesn't have any exponent. It just stays where it's at. Then the x to the negative 2, what happens is the negative makes the x come up to the numerator with the 3, and that makes a positive 2. Now in the denominator, there really is nothing left but 1. And so 3x squared over 1 is just 3x squared, and that's your answer. Okay, I actually have a bonus problem for you. But bear with me, it's pretty easy. I just want to go over one last little thing really quickly. So what if I have something that looks really, really complicated and looks like this, and just kind of making this up as I go along? What if you have something really, really nasty like that? Okay, but then I throw a 0 outside of that. That means that whole thing is raised to the exponent of 0. And so what that means is anything, it doesn't matter what's in here, anything to the 0 power is going to be 1. And that's the magic of the 0 exponent. Okay, so I hope you are good now with 0 and negative exponents, and we'll go over more examples in